This is video 11.4.1, and the goal in this video is to be able to find left-handed and right-handed limits and limits that don't exist. So in order to understand this, let's just remember when we're finding a limit, we sometimes might want to find one-sided limits, meaning the limit on one side. So this is the left-hand side and these are the right-hand side, and figure out what happens when we come from each direction. And we see that both of them tell me that we're getting closer to 4. So that means my limit as we approach 2 is 4 because of the fact that from both directions it gets infinitely close to 4. So these are important for the following reasons. So remember our notation that we talked about in class, that we were looking at the left side and the right side, and the left we talk about it with a negative symbol in the superscript of the thing we're trying to find the limit to, and then a plus symbol when we're coming from the right. So let's say that the limit as we come from the left is L, and the limit as we come from the right is M. So if L equals M, so that the limits are the same from each direction, then the limit exists and it is L or M. It doesn't matter because they're the same. So that means if we look at the table and we see they're pointing to the same number, we can see the limit. But if the two limits are not equal, then the limit does not exist. Some of you asked me about that in class today because you thought of the movie Mean Girls. The limit does not exist if the limit from both directions does not, in fact, equal one another. So you're going to see an example of that in just a moment. This is what we call a piecewise function. A piecewise function says, here's the function when x is less than 1. Okay, but when x becomes 1 or greater than 1, then we're going to use this function. This is the graph of that piecewise function here. Okay, there's two pieces, one when x is less than 1, and the other half is when x is greater than or equal to 1. This is a little more realistic with our real world because sometimes prices jump drastically. Like you would see here, we might jump from here to here when we simply change values. And you'll see that in some examples in your book when you work on your assignment. So this piecewise function, what we notice is that weird jump at 1. So if we were asked for the limit as x approaches 1, we could look at two things. We could look at the limit as x approaches 1 from the right, from the left, and we can look at the limit as x approaches 1 from the right. And we think about, okay, what's happening as we get closer to 1 from the left. So from the left, as we get closer to 1, we see that our function is turning into 2. From the right, as we get closer to 1, we see that it is at the 4. So because these two values are different, we would give an answer of that it does not exist because the values are different. We can't describe what's happening to the limit as we approach 1 because it's different from either direction. We aren't going to average these two and say 3. We're not going to say it's 2 or 4. We're going to say it doesn't exist because they're simply asking what happens as x approaches 1, and we can't describe it. Okay? We can describe the two limits when we're approaching from the left or the right, but we cannot describe the limit as we approach 1 in general. So let's take a look at another example. Here's another piecewise function. So just because it's a piecewise function does not mean the limit does not exist. So take a look at this. We're asked what is the limit as x approaches -2 from the left. So we find -2, we're approaching it from the left, and we see the value is -2. Okay? So my answer here is -2. That has a value. From the left, it's -2. What about the limit as x approaches -2 from the right? That's the next question we're being asked. -2 from the right. So when we're approaching -2 from the right, we're on this red curve, and it looks like we're seeing that it turns into 0. So our answer here is 0. Okay, that's what we're getting closer to. If we plugged in values that are to the right, for instance, -1.9, -1.8, and so on, we would see we're getting infinitely close to 0. Okay, yes, we never equal 0, but we are approaching 0 as we attempt to hit -2 from the right. So if we were asked the following question, what's the limit as x approaches -2, we would say that it does not exist. If that was our question being asked, what happens as x approaches -2? Sometimes they don't exist because they conflict. In this case, they conflicted. One gave us 0, one gave us -2. So what about the next question? The next question, what happens as x approaches 2 from the right? So now we're approaching 2 from the right. So take a look at 2. It's here. And we're approaching from the right, so we're coming in from positive numbers. And it looks like we're approaching -2. The answer here is -2. I know the actual value of the function has a value of 3, and that the red one actually turns into 0, but the actual question, if I'm following this line, I would land at 2. I would make a guess of -2, excuse me, if I was looking at the table of values only on the right-hand side of +2 for x. And that's what the question is asking. Now I look at the negative side with the next question. It's asking me what happens as it approaches x from -2. What happens as it approaches 2 from the left? And now I'm on this red curve, and it looks like I'm going to land at 2. So my answer here is 2. So once again, because these two values conflict, the actual limit as x approaches 2 for the function in this graph does not exist, because there's conflicting answers. But what's really interesting here is the actual value of the function at 2 does exist. There is a value for the function at 2, and it's this blue dot up here. It's 3. So just because the function has a value at that x point, which is 2 in our case, just because it has a value there does not mean that that will be the limit, because sometimes we have this jumping around going on, and we have no description of what's happening when we go close to that point. So this is a very general case of when a limit does not exist, even though the function's value actually does exist. And notice it's not even near the two solutions for the limits when we're coming from the left and the right. Okay? So that's some interesting pieces. Piecewise functions are interesting. Just take your time on them and make sure you ask lots of questions. So here are your checkpoints for today. You're going to try and answer the questions about the different limits of these functions as you approach different values. Be sure to bring in your questions and your solutions to class. If you give the answer of does not exist, make sure that you explain why so that I can check your work and make sure you follow what it means to not exist. So show your work if you feel like the value does not exist, the limit of these functions. Okay, this is, by the way, -1 down, -1/2 down here. And you're using each of the two graphs for each of the questions. So good luck and bring in your questions.